if you can track down the diseases in your family, if you have a disorder, if you got it from your mom or if you got it from father. So a pedigree analysis is like family tree. I showed you, one for the royal family of England. Pedigree analysis is going to show you the relationships and the phenotypes. In the pedigree analysis, this is what normal female and male looks like. You have circles for female, squares for male. Carrier is going to be half colored. Um, Circles for female and squares for male. Affected is fully colored. And then this number, Roman numeral 1, 2, 3, is representing the generations. In this example, let's see. So you have a chondroplasia male, a dwarf male. So let's see, that's a dwarf male. And then he marries somebody who is a regular height. So this is showing, chondroplasia female, but let's just pretend that this is a regular height female. Even though this is something you can see, let's say maybe, you still wanted to kind of go and track down where you got it from. So they're going to have children who are going to be normal height. And they're going to have children that are, maybe have the chondroplasia. And then same thing for the grandchildren. So you can kind of draw this out, even for the traits that cannot be seen physically. So you can draw this out, and then you can try to see if you got it from your mom or you got it from your father. So it can track down the dominant disorders, also the recessive disorders, but it kind of helps you out to understand where you got it from. If you go to the doctor and you ask them, oh, I want to know where I got this genetic disorder from or who I got it from, then they're going to do a pedigree analysis, and they maybe do the genome mapping for your parents, and they try to find the gene. And then whoever has it, they passed it down. And they can also see if he's a carrier for it, if she's a carrier for it, if she has both of the affected alleles. This one is showing that it can also track down X-linked recessive disorders. And X-linked recessive disorders, I think I said it multiple times already, more males are affected than females. So you have more males that are affected. Again, the reason, they don't have a backup X chromosome. They only have one X chromosome. Females have two X chromosomes. For them to be affected, both of the X chromosomes need to be affected or mutated. This slide is talking about how environment can alter phenotypes. Phenotypes are the traits again. So genes are affected by the environment. This is a Siamese cat. Siamese cat has an enzyme. So there's a gene or enzyme, you can say, that's responsible for pigment in the fur. So the feet of this cat are cold, the tail is cold, there is air, touching the face, maybe that's cold, and the ears are cold. Wherever there is a cool body part, it's going to have dark color fur, in this case black fur. So environment is affecting the fur color. If it's warmer here, maybe it will have a different color of fur. So environment can activate or deactivate genes. If you are constantly stressed out, maybe your job is stressing you out or school is stressing you out, and you have anxiety, over time it's going to start affecting your genes, and it's gonna either start turning them off or turning them on, and then maybe you're gonna get high blood pressure, or you're gonna have some maybe also mental issues and then psychological issues. So long-term and stress and anxiety can also affect the genes. So maybe try to, if you do have a job that's very stressful, try to do meditation so you can kind of keep it in check. So this is opposite of the pleiotropic. Pleiotropic, I said one gene can have multiple effects. Here, the skin color is polygenic. Poly means multiple, genic genes. That means there's multiple genes that is responsible for the phenotype. In this case, we're talking about skin color. You have dark skin color, then you have light skin color, and then you have everything in between. So there's more than one gene that's affecting the phenotype, in this case, the skin color. So skin color is a polygenic trait. Same thing maybe for eye color. You have brown eyes, you have blue eyes, you have hazel, green, they're all different colors. So there's more than one gene that's affecting the eye color.